record with this computer. And then let me share my screen. Okay, I hope you see that now. So let's continue. So we already assigned this. Let me just do it again so that we assign our z-axis to be here, and this axis to be here, and this axis, the origin is there, to be there. Okay, so this is z0, that is z1, and that is z2, and that is z3. Okay, we followed the first part of the convention, that zi minus 1 joint I rotates about zi minus 1. Okay, and we already explained why in the most case the n effector direction of the frames, orientation of the frames are similar, are identical or coincident with the n minus 1 frame or the frame before it. So now let's check about xi. Xi common normal and intersecting both zi and zi minus 1. So let's start with, okay, here we say that this is z0 axis is z0 direction of that axis is arbitrary. You can choose x0 to be here, you can choose x0 to be there, you can choose x0 to be there. It doesn't matter. Okay, for now we choose x0 for convenience. Of course, horizontal is normally x0 and vertical is y0. So now we choose that convention. Okay, so x0 finish. So we know that frame 0 is here. Okay, so next we move to frame 1. So frame 1, now we need to know where is the direction of x1. So we say that x1 is what? X1 is common normal to both z1 and z0. Okay, common normal and intersecting. Okay, normal and intersecting. So now let's check. So we want our x1 to be normal. Okay, normal, that means perpendicular to z1 and z0. Okay, so if we choose our x1 to be here, okay, well, we can choose x1 to be here, for example. Nothing is stopping us from x1 to be here. Okay, let me change that color. We can use x1 here. Okay, I want x1 here. I just want to be here. Okay. Okay, is it normal to, is it perpendicular to z0 and z1? It is, because x1 is on the plane of the paper and z1 is coming out of the paper. So that is perpendicular. This is perpendicular. And remember, if you just check perpendicularity, you can transform x1 to be here. Is it perpendicular to z0? Yes. Yeah. So I mean, just to check perpendicularity, but x1 is not really, x1 is here. Okay. So that's okay. It is normal to both z1 and z0. But is it intersecting to both z1 and z0? It is intersecting to z1, yes, because they have common origin. But is it intersecting to z0? No, it's not intersecting. So here, the line is here over here. Okay, that's x1. Okay, it can go along a very long line. Yeah, it's go up to from negative infinity to positive infinity, but it will never intersect z0 in that case. Okay, z0 is coming out of the paper and there's no way they can intersect. Okay, the shortest path between them is this one. The shortest distance between them is that, and that's all. They will never intersect. So how do we make them intersect? We will rotate x1. We rotate x1 so that x1 becomes here. So now if x1 is here, there, okay, it intersects z0 and intersects z1 there. That is what I'm talking about before, when you try to rotate the axis so that it can satisfy certain conditions. Okay, so now in this case we have found our, don't be too picky. As long as we found one, that's it. You know, no need to find, is there a better one? No, don't be so choosy. Yeah, as long as there's one that is working, that's it. So now this is your x1. x1 direction. It is perpendicular to z1, perpendicular to z0, and intersecting z1 and intersecting z0. Okay, so now this is your origin of frame 1. We found it. Okay, next. Where is your x2? Again, your x2 can be anywhere. You can find you. I want my x2 to be here. Okay, again on the plane of the paper. It's perpendicular to z2, but is that perpendicular to z1? Just to check perpendicularity. That's your x2. Yes, it is perpendicular because this is on the plane of the paper and z1 is coming out of the paper. It's perpendicular. Okay, but is it intersecting? We transform it here, it intersects, but this is not the real line. The real line is here. It doesn't intersect. Okay, x2 doesn't intersect z1. It only intersects z2, but not z1. Remember, there are two conditions. One condition is that perpendicularity or normal to both z1 and z2. That's already satisfied. But intersecting z2 and z1 was not satisfied. It intersects only z2, but it didn't intersect z1. Again, we need to rotate. We rotate here so that your x2 becomes that, and the whole line is this. The negative x2 in this direction. So in that case now, it is perpendicular, yeah, perpendicular and also perpendicular, because this is coming out of the, how do we, there, okay. It's perpendicular and intersecting, both z1 and perpendicular and intersecting to z2. How do we, like this? Okay. Okay. So just to make it clear, let's make it cleaner. Let's remove the rest of them. We know that the x2 that satisfies the two conditions is this x2. Okay, there. So now we define frame 2. We know the origin of frame 2 and also where the axis of z2 and x2 are. Okay, so we said that our z3 will be coincident with the direction of the previous frame, that is z2. That is the axis of frame 3 will be coincident with the axis of frame 2. So if we follow that convention, we say that x3 is here. Okay, again, we said that it is perpendicular. We have already checked this one before. It is perpendicular to both. Oh, let me change the color so that it will be clearer. Okay, another color. Okay. That is x3. And it's perpendicular to z3 and also perpendicular to z2 and intersecting z2 and intersecting z3. Okay, now that's satisfied. And so we say that this is your frame 3. So now all frames are assigned. We are done with the first part of the DH convention to say attach the frames to each joints. Okay, including the end effector. So now we need to derive the DH parameters. Okay, that is alpha, A1, alpha 1, AI, alpha I, DI, and theta. And their theta is not very, theta I. Okay. So now, because in this case, theta I is the variable, okay, we normally just, in this case, we don't know what exactly this angle is. We can put 30 degrees probably, but it just is easy to just say theta 1 because they are theta 2 and theta 3. Okay, easy. How? Well, theta moves from here, from Z0. Okay, let's just go back to the convention so that you can. Now I need to open another document. Not this one. This convention, I'll open it here so that you can. Okay, and then we remove the annotation, clear all. Single page, this one. Never mind, our drawings are lost, it's fine. The nice thing about committing mistakes is that there's another chance to do it one more time, and the next time that you do it, you will do it a lot better. Okay, so now, so this is okay, let's have red for frame 0, as it's 0, frame 0. Okay, x0 is here, of course, x0. Okay, now next, red, green for Z1. And of course, this is your X1. And this is your frame 1. Okay, next is about blue. Okay, these are RGB. So again, this is parallel. So this is Z2. And this is your X2. Okay, let me, and then your, maybe, what's the next, orange for the direction change. So never mind, let's make it parallel here. Z3. And this is here the origin. I want to emphasize on the origin. Redo. Okay, and then I emphasize the origin here. This is the origin of the end effector. Parallel is here, so that's Z3, and then your X3 is there. Okay, let me emphasize the rest of them. This is the origin of frame 1 and origin of frame 0. Okay, and then let me finish this. This is your frame 3. And then the blue one, this is your frame 2. Okay, now we are done with all the frame attachments, and now we'll check on the 4 DH parameters. So let's start with theta 1. Okay, so now this is your theta. So theta rotates about Z(I minus 1). So theta 1 rotates about Z0 from X0 to X1. Okay, so where is your X0? X0 is here. Okay, from X0 to X1. X1 is there, rotates about Z0. Okay, so that is your Z0 from X0. From here, so right-hand rule, your Z0, and then your X0, and then go to X1, where X from here to there, rotating about here. So that is your theta 1. Okay, starting from here to there, theta 1. Because it is a variable, it's theta 1. Okay, we don't know exactly what it is. If it was easy to see, we can assign it 90 degrees or something, but we don't know this. Maybe it's 30 degrees, but it's just an approximation. So the best way to say is that this is theta 1, because anyway, that's a variable. Okay. Okay, so maybe it's easier to go to theta 2, yeah, because we know the direction of x1 and x2. So let's go to theta 2. So theta 2 is about z1, okay, from x1 to x2, yeah? Or no, is that theta 2? Yes. We are rotating about theta 2 and rotating about z1. So this is your z1, okay, z1, okay, about z, okay, theta 2 is about z1. So this z1 and theta 2 is from here to there, from x1. So this is your x1, from x1, and that is your x2. So from x1 to x2, there you go, rotating about z1. So that's your theta 2. Okay, your theta 3 is rotating about z2. So that is your z2 from x2 to x3. So x2 to x3. So about z2, again, by right-hand rule, from x2 to x3, okay, rotating about z2. That's theta 3. Okay, now we finish the theta conventions. Any questions? Okay, no questions. Let's go to the next parameter. So you have done theta. So next, let's choose another. So we do alpha I. So alpha I is here. Okay, let's check. So about xi, okay, so rotate, yeah, rotate about xi from zi minus 1 to zi. So about xi, that means for alpha I, for means alpha 1, you rotate about x1. So where is your x1? x1 is here. Okay, that's x1. You rotate about x1. Okay, rotate about x1. Yeah, rotation. You make your thumb in the direction of x1. Okay, x1 from now this part here, from z1, from z0. So z0 is coming out of the paper to z1. Where is z1? Also coming out of the paper. Is there rotation? No, because z0 and z1 are parallel. They don't move about x1. z0 and z1, z0 and z1. Yeah, no rotation. So that's 0. They are parallel. Okay, now let's move to alpha 2. So alpha 2, again, rotate about x2. Okay, where is x2? This is x2. So x2, again, you move your thumb to the direction of x2, and then from z1. So where is your z1? Coming out of the paper to z2. Your z2 is coming out of the paper also, and they're parallel. So again, there's no rotation. You don't rotate about x2 to go from z1 to z2. Nothing. They are in the same direction. Wow, I can see you doing like this. And you, wow. You understand?
I'm still trying to figure it out, sir. Still looking at the image too. I'm trying to understand.
Okay. Which part? Okay. Do you understand the part that your thumb has gone in the direction of x2? You understand that part?
Yes, sir.
Yeah. Take your thumb. Okay. Look at the screen. Take your thumb out in the direction of x2. Okay. And then here, this part, the 4 fingers in the direction of z1. Okay. To make it easy, because these are rotation. Remember, when you're doing rotations, we can transform the matrices to make it easier. Okay. Let's transform them. Let's transform this origin to here. Okay. So that means your x2 extends here. Okay. And then your z1 is here, and also your z2 is there for easy understanding. Okay, so your axis x2 is there. So now your x1, your z1 is in that direction. Your z2 is also in that direction. Now you put your thumb now in the direction of z2. Wow, come on. Put your thumb out in the direction of x2, and these 4 fingers in the direction of z1 coming out of the paper. Yeah. So now like that, that is your z1. And then you rotate towards z2, from z1 to z2. That's the, but then to rotate about this x2. No, because now, okay, let's go back. Okay, let's go back to, maybe it's easier because this one is more complicated. Let's go back to frame 0 to frame 1. Okay, let's start from here. Okay, we start from x1. Let's go back, this part here. So if we say x1, let's make it a different color. We make our x1 extends to here, yeah? X1 can extend. Okay, so that x1 is that, that's okay. And then we also say that your z1 is here. Just for easy reference, so that we can easily understand. So now, can you put your thumb in the direction of x1? Thumb in the direction of x1. Wow, come on. Your thumb in the direction of x1. And then your 4 fingers in the direction of z0. Can you do that? Z0 is coming out of the paper. Okay, that is a plane. X1 is in the plane of the paper, and then Z0 is coming out of the plane of the paper. Okay. Now, the problem here is there's no rotation, so we cannot see. But if there was a rotation, Z0 going to Z1, you know, it will sweep that rotation. Okay, maybe let's go to, okay, the best way is, I want you to understand clearly. So let's go back to theta. I think theta is the easiest one in this case, because right now it's difficult to imagine because there's no rotation. Let's start with Z0. And this is Z1, they're parallel. What is theta I? Theta I is about theta 1. Okay, theta 1 is about, okay, let's just write here. Theta 1 is about Z0 from X0 to X1. Okay, is that clear? The convention, theta 1 is rotation about Z0 from X0 to X1. Okay, so now put your thumb out, your thumb going out of the paper. Okay, and then these 4 things along X0. These 4 fingers in the direction of X0, it should be like this. Okay, okay, and then this is your Z0. Okay, put your mouth on your thumb. Put your mouth on your thumb, and then hold the thumb and rotate, sweep along X1 there. This is X0. You rotate X1. Do you see that? Now your 4 fingers is in the direction of X1 now. Wow.
Now I get it, say.
Ah, I see. I know that the trick of sucking on your thumb will do the trick. Yeah. Yeah. So you see, this is the axis of rotation. Yeah. And then you just do X0 and then sweep to X1. That is your theta 1. Yeah. The same thing. The same thing in terms of alpha. Yeah. So in this case, let's go back to alpha. Now you check the alpha. So alpha 1. So now let's do alpha 1. Let's change this one. So alpha 1 is about x1. Okay, now we consider x1. Where is x1? This is x1. Okay, when we are doing alpha 1, we do x1. So about x1 from z0 to z1. Where is z0? This is z0 to z1. That's z1. Okay, so now, so again, put your thumb into x1, direction of x1, and then the 4 fingers in the direction of z0. Now we rotate about x1. So x0 is in that direction. But, I mean, sorry, z0 is in that direction. x1 is in that direction. So you rotate about x1 from z0 to z1. But in this case, when you rotate about like that, there's no rotation because z0 and z1 in the same direction. You don't rotate. Yeah, they are parallel. There's no rotation that is being done. And so that's why this is 0. Okay, so if we move to x2, yeah, let's make it a different color. Okay, can somebody stick his thumb out? Obaking. You put your thumb in the direction of x2. Where is the direction of x2? Going up. Yeah, you see that? So now these 4 fingers. Okay, so now because you are considering x2, so we say alpha 2, okay, about x2, okay, from z1 to z2. Okay, you put your finger, I mean your thumb on x2. Yeah, so this is x2. And then now point your the 4 fingers remaining in your hand, point it into where your z1 is. This is your z2. Okay, so your x2 is in that direction. Point your fingers, the 4 fingers from z1. Okay, rotate towards z2, but your z2 rotating about your thumb. Can you rotate about your sweep from z1, rotate to z2 about your thumb? You cannot see that? Okay, this is z2. Okay, let's extend z2. Okay, and if you extend z2 there, I mean, sorry, this is x2. We extend up to here. And then now your z1 is in that direction. That is also the direction of your z2. You extend your x2 there. We also extend your z2 here. Okay, so now that is z2, that also z1. So if you have your x2, your finger now, come on, thumb, put your finger now into x2, and then the 4 remaining fingers in your hand go in the direction of z1, out of the paper. And then sweep, rotate about z2. But now you don't rotate because z1 and z2 are coincident. There's no rotation. Huh? If z2 was here, if z2 was there, then there is a rotation of alpha 2. Do you see that? If you rotate, then there is if z2 was in that direction, then there is that alpha 2 angle. But there's none because z2 is not there. Z2 is here. So that's why it is 0. Tom?
Yes, it's crystal clear.
Okay. Okay, you'll be comfortable later on. The next, let's do alpha 3. Yeah. So in terms of alpha 3, let's erase this. Let's erase this. Okay, let's erase this also. So in terms of alpha 3, so again, we write alpha 3, okay, about x3. Now we consider x3 from z2 to z3. Z. Okay, so now this is alpha 3. Sorry, we're considering alpha 3 and we are considering x3. Where's x3? This is x3. Let me change the color. This is x3 and your now the direction is let me change a bit, just a little bit. Okay, that is your z3. Okay, and this is your x3. So you stick out your thumb again in Z3, put your thumb there along Z3, and then now your Z2, okay, you can bring it down here so that for easy, and bring down X3 here, and then that is your X2, but that is your Z2, but this is also your Z3 because they are parallel. So now from Z3 rotation about from X3 rotation about X3 from Z2 to Z3. Again, Z2 is this pointing of the four fingers in your hand, and then this from Z2 to Z3. But Z2 in this direction rotate about X3. So but now your Z3 does not rotate. I mean, there's no change in orientation. But if your Z3 was again here, if your Z3 was here, then there will be rotation. Okay, your X3, and then from Z2 rotate to Z3. Okay, that will be your alpha. But because Z3 is not there, they are coincident, then again your alpha is 0. Okay. Okay, now let's continue. Okay, let's just continue with this, finish this one up in the next. Let's consider another example because now the planar, maybe it's not good for you to imagine. And then let's go alphas. I mean D here, D. Okay, let's consider D because it will follow the convention here. Let's consider D. So if D, so DI, so D1, so along Z0, from origin of frame 0 to intersection of Z0 and X1. Okay, so there are two things that you need to consider. The origin, there are 2 points. Origin of frame 0. Where's the origin of frame 0? This origin of frame 0 to the intersection of Z0 and X1. Where is X1? X1. Where is Z0? This one. Where is the intersection of X1 and Z0? That one. Is the same as the origin of frame 0. So there's no distance. That's 0. Okay. Origin of frame 0 there. To the intersection of Z0 and X1. Intersection of Z0 and X1 also there. So there's no distance. That's 0. Okay. Next, we consider D2. So D2, so that's D2 along Z1 from origin of frame 1 to the intersection of Z0, what's this? Okay, Z1, 2, and X2. Okay, where's origin of frame 1? Origin of frame 1 is here. This is frame 1. Remember? Frame 0 is here. So this is origin of frame 1. To the intersection of Z1. Where is Z1? Z1 is this. Okay, let's erase some things that will make us get confused because we transfer it before just for understanding. Now, okay, that is your Z1 and origin of frame 1. Okay, to the intersection of Z1 and X2. Where is your X2? That is your X2. Where is your Z1? This one. The intersection, okay. Origin of frame 1, origin of frame 1 to intersection of Z1 and X2. Z1 and X2 intersection is also this one. They're the same. So again, that's 0. Okay. So let's finish day 3. So maybe you are already seeing the pattern. So if you do D3, so D3 along Z2, we didn't even have to see where Z2 is because the origins are already coincident. Origin of frame, what is now? Frame 2 to intersection of Z2 and X3. So where is the origin of frame 2? So this is frame 1, this is frame 2. The origin is here. And then intersection of frame, intersection of Z2, this is your Z2, yeah, Z2. Intersection of Z2 and X3. X3 is here. X3, go down here. That's also the intersection of X3 and Z2. That's also the frame, the origin of frame 2. And so again, that's 0. Okay. Then let's move on to A1. Okay, so A1 now. Let's consider this. So now again, this is the distance. So along X1. So A1, if you consider A1, now you are looking at X1. So this is X1 along here. Okay, that means there is that direction from here to there. Okay, or from here to there, from here to there. Along X1, from intersection of Z, from intersection of, okay, this is, sorry, this is A1, X1, intersection of Z0 and X1, and what is this? Frame 1. Okay, intersection of Z0 and X1. Where is intersection of Z0 and X1? X1, Z0. That is the intersection. Intersection of Z0 and X1. Okay, from that intersection to the origin of frame 1. So where's origin of frame 1? This is the origin of frame 1. Okay, from here to there along X1. So from here to there. So from here to there along X1. So that is A1. Is that positive or negative? Kurata?
Come again, sir.
Is A1 positive or negative? You were busy with your phone.
No, sir.
So,
I was a bit behind.
you were a bit behind. Are you sure it's just a bit only?
Yes.
Okay. So is that
yes,
positive?
sir. I was still looking at A1.
Yes.
You said it's along X1
Yes.
and intersection with Z0
Z0, yes, and X1.
and X1.
Where is that? Where's the intersection?
It's at the origin.
Okay, very good. Okay. And then to where? From that point in the origin to?
From that point to the origin of X.
Origin of frame. Origin of frame. From here to?
So I don't see where you're pointing.
Oh, you don't see?
Oh, I can see it now.
Okay, I put the spot. This one. Okay, from the origin to where?
to the origin of x1.
No, to the origin of frame 1. Frame, the whole
Oh,
frame.
frame.
Yeah, so this is the origin of frame 1. Very good. So from here, okay, to the base frame, or I mean to the origin. Okay, frame 0, origin of frame 0 to origin of frame 1 along x1. So is that positive or negative? From here to there.
It's positive.
It's positive because from here to there is the positive direction of x1, right? So that's why it's positive. Very good. Okay, so that's why A1 here, that's A1, and it's positive. It's not shown, but that's positive. Unless it's negative, they will show, but that's positive. Okay. So now let's do A2. A2 along again x2. Just follow 2, 2. So this one is Z1 and x2. That's the intersection, origin of frame 2. Okay. Where is origin of frame 2? Here. We know that. Where's the intersection of Z1 and x2? That is x2 and Z1 here. Z1 and x2. The intersection is here. Okay. From here to there. That's what it's saying. From that intersection to the origin. So from here to there along x2. So x2 is there. So from here to there along x2, what is that distance? From here to there, that's A2. Yeah. And then in that direction, in the positive direction, and so that's positive. A2. Tom, your lips tell me something. Are you seeing? Ito Meleng.
Yes, I can see that.
Are you sure?
Yes, sir, I can see.
You have to do the exercise, mental exercise, so you can. Okay. Okay. Let's continue. Then the last one is A3. So A3, okay, let me delete this. Okay. So again, what color I didn't. Okay, I want a darker color. So now you have A3 along X3, intersection of Z2 and X3, frame 3. So let's start with that one first. Origin of frame 3. Where's origin of frame 3? This one. We know that this is frame 3. Okay. That's the origin of frame 3. Intersection of Z2 and X3. That's X3 and this is Z2. That's the intersection. Okay. So along X3. So X3. Along X3. There. Along X3. From this to there. From this point to that point. Along the intersection of Z2 and X3. Z2 and X3. From this intersection to the origin. To that one. Along X3. So now that's A3. And again, that's positive because in the positive direction. Okay, finish. We are done. Okay, we are done looking at all the parameters. And if we take all the transformation matrix for each from theta 1 to theta 2, okay, theta 1 to theta 2, because they are planar, here is the transformation from, for example, transformation from A0, that will be A0, I mean 0 A1, okay, that is equal to 1 A2 equal to 1A. Equal meaning, I mean, it's not really equivalent. I mean, they're just not really equal, but then equivalent based on this. They are using the same transformation matrix. The only difference is that the indices. Yeah. So if this is 0 to A1, this is cosine theta 1, sine theta 1, like that. sine minus sine theta 1 cosine theta 1, and this is the position. Okay, position vector. So now, if you consider from the base frame to the end effector frame, this is the transformation matrix. Okay, so if you see that, this is the rotation matrix. Okay, and this is the position vector. One thing I want to let you understand is that, see, the z-axis, along the z-axis is 0. It doesn't move along the z-axis. Yes, because the robot remains on the plane. It doesn't go out of the plane. So that's 0. See? And then, are you familiar with this? I have written this. This is the x, and this is the y. Okay? It used to be L1. This is L1 C1 plus L2 C12 plus L3 C123. There. This was L1 S1. This is the one that we've been dealing with for the planar robot. Right? Yes. You are also able to derive this expression based on the transformation matrices. That's why I started with the planar robot, so that now you can see that even with the planar, also it's simpler. Even with the planar robot, you can also do the pH parameters and confirm with what we did. We can derive the analytical derivation we did before, okay, using the transformation matrices. Okay. Any questions? Okay, for the last 10 minutes, we will discuss another example, because I think it's the more examples that I do here, the better for you. Okay. Okay, let's do the last example for this meeting. Okay, I don't know if you can finish it, but we'll just I'll just do as I'll just do with time. Okay, so now, how do we do this? So which are the joints? So this is theta 1. So this one is there. There's theta 1 already. We'll make it bigger. It rotates about that. Okay. So where is your theta 2? Theta 2 is here. And in this case, there's no theta 3. Okay. In this case, this is prismatic. It's going up and down. Okay. So now the variable is D3, this one. It goes up and down. Okay. Okay. Never mind. Don't be scared. Let's just look at the convention. Okay. So we say that the axis of rotation, okay, is always the axis of Zi minus 1 is always the axis where joint I rotates. Yeah. So now, because theta 1 rotates about this one, so we know that your Z1 axis will be along here. Okay. I mean, Z0 axis will be along there. And then because theta 2 rotates about there, so we know that your Z1 will be here. Theta 2 rotates about Z1. Okay. What about this one, this movement, Z3? I mean, the movement of D3. Well, in this case, it's not joint I rotates about ZI. So Z will be along this axis also. So Z will be along this one. This is where the axis of motion for D3 is. So again, this is Z is rotates or translates. Okay, in this case, it's not rotate, but translates. Joint 3 translates along Z2. So this is your Z2 axis. Okay. Is that clear? Okay, it translates. This this block here goes up and down. Okay, so that means that joint 3, the joint 3, that one that moves up and down, translates about Z2. So now Z2 is along here. So we have assigned that. So all the Z's are assigned already. All the Z axes are assigned already. Now we need to know where are the X's. So the X axis, so we can know where is the origin of each reference frames, right? So now let's consider where is your X1. So we say X1 is normal and intersecting to both Z1 and Z0. So where is your, okay, first of all, we don't know yet where is your base frame. Okay, we need to assign first your X0 and Y0. Okay, so if we, for example, consider your X0 to be maybe, let's just assign X0 here. X0. Okay, if that is X0, your Y0 will be here. Okay, we can arbitrarily assign where is your base frame. Now, we need to know based on this base frame, where is your X1. So we say X1 is common normal and intersecting to both Z1 and Z0. Okay, so it has to be common normal. So normal and intersecting. So where is your Z1? Z1 is here. So we need to find where is your X1. So it should be normal to Z1. So it's either this one, it's either this one. It could be your X1 in that direction because that's normal to Z1, or it could be going up. That's also normal to Z1. This is also possible. Do you agree? Those are the two directions, yeah, that are possible for X1 for it to be normal to Z1. Okay, now, so which one is normal? We also need to be normal to Z0. Where is Z0? Z0 is here. Okay, this is Z0. Okay, this one is not normal to Z0, so this one is not possible. Yeah, that is parallel to, that is not possible. So we choose this. That is normal to Z0 and normal to Z1. Okay, now the next one, is it intersecting? Is it intersecting to Z1? Yes, of course, it is intersecting. What about to Z0? Is it intersecting? Well, Z0 is there. Yes, it is intersecting. Tom, don't shake your head. It is intersecting. There, that's Z0. Okay, that is Z0. X1 is there. This is your Z0, and this is your X1. It intersects. X1 intersects Z0. And it is also normal to, that is also normal to Z0. X1 intersects and normal to Z0, and X1 intersects and normal to Z1 there. Okay, so X1 is really there. Yes. Can you say something?
Did I get it now, sir?
You get it now?
Yes, sir.
Okay, very good. Next, before the time ends, I have 2 minutes. So now I will need to know where is your X2. So your X2 needs to be common normal and intersecting both Z2 and Z1. Okay, so Z2 is here. Z2 is there, and now it needs to be intersecting and normal. Okay, so if that is the direction of Z2, what is normal to, it could be here. That could be your X2, or again, it could be in that direction. This could be your X2. Okay, but we also need to be normal to Z1. Where is your Z1? Your Z1 is here. So this is not possible. Okay, so X2 should be here. So now, is X2 normal to Z2? Yes. Is this intersecting to Z2? Yes. Okay. Is X2 normal to Z1? Yes, it's normal. Is it intersecting? Yes. And so X2 is here. Okay. So in the offer, the direction X2 is there, but maybe we can, okay, let's just choose X2 to be in the positive direction, to be here, just negative X2, so that we can follow the convention here. So here, this is your X2, positive, and this direction is X2 negative. Understand? And then now going to the end effector frame, we already mentioned, just for convenience, just follow the, you can put it somewhere, just follow the orientation, the orientation of the last n-1 frame. And so the frame 2 is this, frame 3 can be the same orientation. There, that's frame 3. Just put it there where the hand is. I think the real picture is here, like this. This one is long like that. Okay. Any questions? Now we covered, okay, it's 1 o'clock already. We covered how the frames are assigned. Then later we will see how these parameters are being derived. Okay, I hope it is clearer now. Any questions? I can get one question before we call it a day, just for less than a minute. Nothing? Okay, so in the next meeting, we are going to wrap up this. We'll get two more examples, and then we'll go to controls. Okay, the next to control and full space control. And then if you have more time, you'll do redundant robots. Then you will be very ready for robot control. Okay. Okay, thank you very much, guys. Hopefully I will be able to upload then I will give you exercise already. Okay, I think you're ready for the exercise on the lab. You think? This coming Friday? Okay, let's check. Yeah, never mind. Let's do the lab and see if you can do it. Yeah, and then we will wrap up. You will learn on your own, and then next meeting we will wrap up your learning. Okay, so that you will try. Yeah, just run through the video again. For sure you will understand. There's once you've experienced the pain, then that's how you really get to learn. There's no pain and no learning. Just sitting down like watching a movie. Okay. Okay, anyway, I think you're ready. I think you have the basic grasp of what's going on, and then that basic information we will nail the final nail. We'll put the final nail next meeting. Okay, so I will give you an exercise this coming Friday. DH convention, DH parameters. Okay. Okay. See you guys. Thank you. Bye.